homework because uh, someone of you may have some problem about the math, right? Uh,
Uh,
actually, actually, for me, it's not that difficult for me, but there's something difficult for me in how to express this terminology in English. Actually, if we try to solve this problem, we have to use maybe 三角函数. It's hard for me to read this, maybe trigonometric function, right? And the hard one is this. Actually, we Chinese call that 勾股定理. And for me, it's very difficult. Maybe it's famous philosophy's name, right? Actually, we Chinese call this guy with Pythagoras. So it should be Pythagoras theorem. And another thing about right triangle. So actually, before our today's class start, actually, you guys can see I read something on the screen. When we try to find, try to determine some motional equation of a point. So you guys can see, although this homework can tell us how to determine the motional equation of slider B, actual slider B, we can look at it or treat it as a rigid body, right? But we have learned two types of simple motion of rigid body. The one is translational movement. Actually, you guys can see that slider B will always along this horizontal line, right? In other words, we can look at this. Actually, this dash straight horizontal line can be used to denote the path or trajectory of this point B, right? So actually, because this letter B has a translational moment, we only need to figure out just one point on this letter to get the total moment information of this letter. So actually, we are going to find the moment of the motional equation of this point B. So I read some steps here. The first, we should build a coordinate system. So from this, it's highly recommended that we use this point O as the original point. So we give x-axis and y-axis, right? So this is the first step we build coordinate system to help us to solve the problem. The second one should be, we should link the point. This point is the point we are trying to find its motion information, right? So you guys can see we link OB and we have a vector OB, right? So actually at different time moments, we know actually the magnitude and the magnitude, right? The magnitude and the direction of this vector OB will be changed according to different time moment. That is, we can see OB is the function of t, right? So if we can figure out its law of changing, its changeable law, we can find the motion information. So the second step, we should try to find a vector loop. So you guys can find, we can draw a line OA, and then we draw another line from A to B. So we have a vector loop. You see, this is the OB, vector OB can equal OA plus AB, right? So we have an arrow on these letters to show this, all these three guys are vector, are vector. So this is the vector equation. Then we should, with the reference of this coordinate system, to find its magnitude and the direction. So we do not need to figure out the magnitude and direction of AB, because when we finish this, we try to projection this vector equation onto x-axis and the y-axis respectively. Then we'll get xb and yb, right? Actually, in this problem, we only need to project this vector equation onto x-axis, because we only try to figure out the xt of b, because we know b always along the horizontal line, right? So its y will always be 0. So we'll see that. So we'll look at the right part of this equal sign. So we have OA and plus AB. So you guys should always pay attention to the direction of this vector. So we always select the start line with the positive direction of x-axis, and the CCW direction will be positive. So you can see, you can imagine that we try to rotate this positive direction x along CCW direction. When this arrow will overlap with this OA, we will stop this process. Then we'll find there will be an intersecting angle phi. So we have the direction. This angle will show the direction of this vector OA. So we have plus or positive phi because it's along CCW direction, right? So this is OA. And this is AB. So we try to find its direction. So we can draw a aided line, which is parallel to our x-axis. So this one is parallel to this one. So if we see that this angle is theta, let's say this angle is theta, then because this line parallel to this line, also parallel to this horizontal line, right? So we all know that this angle will equal to this angle. But you guys can find, actually this time, we use the same direction of the positive direction of x-axis, but we along CW direction, clockwise, right? So in China, we call it this CW with 顺时针, and this CCW with 逆时针. So this time, because we use this CW direction is very convenient for us to find this angle. So this time we give minus theta. So you guys should always pay attention to this process. When you try to figure out the direction of a vector, you should think about that. What direction you are along, CCW or CW? Then you should give a plus sign or minus sign accordingly, right? And the magnitude of these two vectors is very easy. So we know OA equal R and AB always equal L, right? So we finished to figure out this magnitude and direction of OA and AB. So we can just projection this vector equation onto x-axis. It's very easy. You guys can follow me. So we should from left side to the right side. So OB, when OB projection onto x, then we'll get x, right? Actually, it's coordinate of this point B. So we just write as x or xt. This equal sign will just copy from here to here. So x equal, then when we project onto x-axis, we should always use this magnitude times cosine this angle. So we have r times cosine phi, right? Plus, because we have a plus L cosine minus theta. You see? So because this cosine minus theta will equal to cosine theta, it is the characteristic of cosine function. I think you guys should know that from
Okay,
mathematics, right?
this is
So it's
L
very
cos,
easy,
this is minus theta. It's how?
right? Until now, can you guys understand?
Understand R cos phi plus L cos of minus theta. This is, I can understand this minus theta.
So can you totally understand this expression? Actually, just because we project,
Or this one.
yes, you don't know why, cosine minus theta equal cosine theta, right? You don't
Yeah,
know this.
yeah, that's right. But where we find this minus theta?
Do you know that concept R the function? Do you know that? Actually, this is a mathematical point, knowledge point. Do you know R the function? So if we have we set some function in the R function, then we'll have f minus x will equal minus fx. Actually, maybe it's a characteristic of this trigonometric function. So you should know that maybe sine, sine minus x will equal minus sine x. I think maybe that's kind of a theorem. I cannot to explain to you why it's this because I think it's from mathematical knowledge point, but
Yeah,
cosine, cosine x is not odd function. Actually, it opposite odd function. We Chinese call that 偶函数, you know, 偶函数. So when we call about some 偶函数 means f minus x will equal fx, just like this cosine. So when we see cosine minus theta equals cosine theta, I I hope you guys you can understand me, but I think I cannot explain this to you further. It's just more like a theorem from mathematical knowledge point. No? So maybe you can check it by yourself. Okay?
yeah. Actually, basically, I understand cos of L cos of minus theta equal to L cos theta. That's fine. My main point is a cos. How we find L cos minus theta. This one. I understand this one.
Oh, you understand this one?
Where we find L cos of minus theta. This one. Why we write here minus? We can write here plus theta. L cos
Uh,
theta, only cos theta without minus sign.
let's say you mean I think you mean uh the latest thing how we find this cosine theta, right?
No, cos of minus theta, there's one. That one.
Because we just
That one.
guess this angle is theta, right? The the second thing is how to find this cosine theta, right?
Yeah. My
So
question is, Lavshi, L here L cos, we write here L cos minus theta. Can we write here L cos only theta without minus sign?
I'm sorry, I can't
This
hear you
place,
very clearly. I cannot
this
understand
place
what
we
you
can
are
write only theta without minus sign.
without what?
Minus this sign minus sign.
I just said because when we try to figure out its direction of this vector, actually this vector is direction from A to B, right? So you
Yeah,
can see the green arrow, right? So
yeah.
maybe you can just from this horizontal line, which is parallel to x, positive x direction, with CCW direction, you will get a very big angle, which angle should be 360 degree minus theta. So you can. So maybe I can explain to you. So if we, no matter what direction of the vector is, we always along the CCW direction, then we will find actually this angle will be like this, right? So maybe we did know this like phi. So you can find if we try to along the CCW direction and do to close to the start point, we can very easily find actually this per psi equals 300 minus theta. You see?
Yeah.
This is the true expression, right? So you can write like cosine per psi equal cosine 360 degree minus theta, right? But actually this cosine function is 周期性函数 periodical function. So this one just equal cosine minus theta. Because cosine x will always equal cosine 2 times k times pi plus x. Because this 2 times pi is period time, 周期. So if I draw the cosine functions curve, so maybe this s, this cosine x, then it should be, I think it should be like this. If we try to keep drawing it function curve, more like this. So from this star to this star, we call it 周期 t of period time. So you can see from here to here, it's another period time. The shape of the curve is totally equal to the first one. So we have the so-called period function will have this characteristic where ft plus x will always equal fx. That's why we see cosine 360 because it is 2 times pi, right? This cosine 360 minus theta will equal this. So that's why if you along the CW direction, we just get this minus theta directly. Then we just projection onto x, we got this. We'll have the same result. So can you, Mister, you understand that?
Yeah,
Okay, thank you. I try to explain this. It's hard. The hard for me is explain this in English, So that's the main barrier between us is language, right? So if you can accept that you know how we get this expression, so the second thing is how to find cosine theta, right? So actually, I draw another added line. So you see, actually, this should be perpendicular to this horizontal line, right? We got what? We got a right triangle, right? So if we, let's say this point is maybe point E. So you can find actually AEB will be a right triangle, 直角三角形, right? So this sine theta, this theta, actually L times cosine theta. So you can see actually L cosine theta is the length of this, right? Is the length of this. So from this Pythagorean theorem, do you guys know that? Because when we have a right triangle, let's say it has three sides, the length A, B, and C. So we have this 勾股定理 of Glasses theorem. We have this actually A squared, A squared plus B squared equals C squared, right? Actually, if here we have angle theta, then we have sine theta will equal A over C, right? And cosine theta will equal B over C, right? So you can find actually this length is we try to figure out. So we have a very directly measured it. Actually, this L cosine theta is just to find the length of this. So actually, we can rewrite as this R cosine phi plus L squared minus this whole length AE squared, right? And this AE squared. So what AE squared is? So because this one will equal to become, we know that this heat is H, right? It's H plus from here to here, right? This one, actually, you can see that is another right triangle. So this length will be R times sine phi. So this is R sine phi, right? So A squared will equal to this, So we can just write like this, L squared minus AE squared, which is H plus R sine squared, right? Actually, this is angle. Because we know, actually, this is, we have this expression. Because this OA will rotate around point O during this movement. So it's phi equal omega t. That means it will have a constant angular velocity. So actually, we can write again. We just use omega times t, replace this phi. So the final result is maybe R cosine omega t plus squared L squared minus H plus R sine omega t squared. That's how we get the final result. I hope you guys can understand. And you?
Yeah,
Okay. Let's move to the second page. I will give you time that maybe 2 minutes. Actually, this is the homework finished by I think BE 20. Just about you get 1 grade, That's a girl named Rila. So actually he used a different method to find the result. So you guys can look at this. Maybe you guys just please with me 2 minutes. You can think about that. Then I will try to explain this to you guys, right? So with me a minute. Okay, guess I'm back. So let's try to figure out how this girl thinking to finish its answer. So actually you can find this girl do not use the method I have mentioned, do not use the vector loop, you know, but I think she thinks actually she also has a default coordinate system its origin point should also at point O. So if we'll try to determine the motion equation of the letter B, actually it just needs to I think the meaning is just to find xt, right? Because the length means from point B to O, right? So you can see, he tells us, given that crank OA with length R connecting a rod, not N should R, rod AB length L, right? So we know, so you guys can find at this position. Actually, because OA can rotate around point O, it can be different position. Actually, this A will have a circle trajectory. This circle will have radius of R, right? Maybe I try to draw its part of its trajectory, maybe along a circle trajectory. So it can at different position. So at this position, this phi denotes OA's direction or angle, right? So we have, so you guys can find actually the horizontal distance from O to B will be X equal this part R cosine phi, right? R cosine phi plus L cosine theta. Can you guys understand this?
Yes, Raj.
I think it's equal to easy to understand, right? X equal R cosine phi plus L cosine theta. Just the same result from our projection method. So actually, what we have talked projection, we find vector loop and then we do the projection. It's quite generalized, right? It can be used to finish any problem of how to figure out point movement. So the other thing, they try to find a cosine theta. So it has this R, we have H, L sine theta, you know, from this right triangle, L sine theta will be the whole length of this. That's more like the AM I have, AE I have draw on the last page. So this whole length minus R sine phi is this part will be H. So we have L sine theta minus R sine phi equal H. So from this expression, she find R sine theta equal H minus R sine phi over L, right? We from our theorem, because we know sine theta, I forget I can use pen to write sine theta squared plus cosine theta squared always equal 1. This is the main characteristic of 三角函数. Well, it's hard for me to use its English terminal. So you can see we have, it tries to find cosine theta. So cosine theta equals this. This should be squared. And cosine theta equals this, right? So this is this. He find this is the answer. So x equal R cosine phi plus L times square this. So it from this one, maybe we think it is not the same answer from what we have get from the last page, but actually it is, you know, It is. So we can do the simplify. I have read this. So I write its final result here, So we have L times squared 1 minus this. But we can try to simplify. So we have L squared, this part squared. Then this one can be replaced by L squared over L squared, right? Then we can take this L squared out of this squared. Then this L and this L will be eliminate. So this the same result from our method, right? So actually, its result is totally correct, right? So you guys can think at this girl. You guys also can think at what we have talked about. We should try to find a vector loop and then do the projection. So if I erase all the things I have right on the screen today, then we can do another projection, So if we use this same vector equation, this time we project this one onto y-axis, then we will find actually y equal r sine phi, right? Plus L sine minus theta, right? And because I have read this sine theta is odd function, so it should be equal r sine phi minus L sine theta. So you can see, this is r sine phi and this L sine theta. So this result will always equal minus h, right? So because our coordinate system is origin point at here, so you can see the y component of point B, no matter its position here or here or here or anything else, its y coordinate will always be minus h, right? So actually we can find it is true. It have nothing have anything. It can you guys can see it always be minus h. It has nothing to do with time t, right? So it's a constant. So I hope you guys can understand how to use this method through this example, but I also know this is a little bit difficult for you guys to understand totally. So I highly recommend, and I also hope you guys can read our textbook by yourself after our class. So most time we don't cover all the things of this textbook. And if you guys find some part very difficult, you can just skip it because we don't need you guys totally understand all the things on this textbook. I only hope you guys have some basic knowledge of this. So we should continue our class today. We are back to chapter 7. So I think last time we have finished this chapter section 1, section 2. We should start with section 4. But actually this chapter 7 is tell us something about basic motions of rigid body. It's very important because you guys do you prepare for that? Our coming chapter, chapter 8, will very difficult to understand. So I think maybe we should do some review from this chapter 7. I hope you guys can grasp this knowledge points thoroughly, then when we are moving to chapters 8, maybe you guys can understand more, right? So today we'll quickly review what we have learned last time. Then maybe we will finish the final one, transmission between two rotating rigid bodies. Then we'll do some examples that are for today, maybe. So last our task is today we will finish this whole chapter 7. Next time we will move to chapter 8, right? So let's see. About translational motion of a rigid body, it's very easy, right? We don't use too much time to review that. So you guys only should know that when we said body have a translational motion, it means you can arbitrarily select 2 points on this body. Then this 2 points will have these characteristics all the time. VA always equal VB, AA always equal AB, right? The other thing is, when we see a rigid body have a translational motion, it not means it always should be along a straight line. So just more like this parallel linkage mechanism, we call that 平行四边形机构, right? So this linkage will have a curvilinear translation. Also is another translational motion. Any 2 points on this yellow one will have these characteristics. Maybe VB always equal VC and AB always equal AC. That's the main knowledge point of translational movement of a rigid body, right? That tell us why it is. So we will skip all these things because I think it's very easy for you guys to understand. Then, sorry, there's something wrong. Maybe I have to what happened? Why it closed by itself? I just try to move to the next page of this file, but it closed. You know, I don't know. I don't know why. So, let us do a review of this. No, you know, it's quite messy because my handwriting on the screen. So you guys, please, do some. You should familiar with rotation of a rigid body about a fixed axis. It's very important, you know. So the first tell us the feature of rotation about a fixed axis and its simplification. Because I think I just let you guys think about when you open or close your door, actually the movement of the door is a rotation about a fixed axis. So it have angle of rotation and equation of rotation. So we have phi, its angle of rotation, 转动的角度. Its unit will be radians, right? And we have phi equal ft. This equation of rotation, and we have a sign convention. CCW, you know, this is CCW, more like a moment, right? We have mentioned the moment. CCW will be positive, and CW, which is clockwise, will be negative or minus, right? Just follows the right-hand rule. And we also had talk about this angular velocity and angular acceleration. So angular velocity omega actually equal d phi dt. 1 dot of phi, right? So this definition of angular velocity. So if we have this phi equal ft, so from this expression we know our omega, which is angular velocity, should be omega equal f prime t. This prime means actually here f prime p means dft dt. It means derivative calculation, right? And a unit used in engineering will be round per minute. So we should very familiar between that n and omega. You know, so because omega units is read per second, so we have r per minutes. So 1 round is 2 pi, right? So we have n round per 1 minute equals 6 seconds. So this is, so we always should know omega equal n pi over 30, right? It approximately 0.1 n, right? That's what we have learned last time. And another is angular acceleration. Angular acceleration denotes the angular velocity t at omega and t plus delta t. So we have this expression. So this alpha, in my time is a long time ago. We also use epsilon. Another Greek letter to denote this angular acceleration. So when you see some figures to denote this letter to denote angular acceleration, you should know it means the same thing, right? So it's double dot of phi or f double prime t. Its units read per second squared. So so a rigid body has accelerated rotation when alpha and omega have the same sign. So I can show you guys this. So let's say if we have a bar, means OA. So because we know it's along the CW direction omega and also have a theta direction alpha, then we can call that it had accelerated rotation because this alpha and omega had the same size. Actually, we also should know how to figure out any point on this OA is velocity and acceleration. So let's see, we just arbitrarily select the point M at here. Let's say it's point M. So because we know if this OA is a rigid body have a rotation around the fixed point O, any point on this OA will have a circular trajectory. So this M, it will have a circular trajectory, you know? So the first is we try to figure out VM. It should, you should follow my step. So first, you link its rotation center O to this M. You see, you got this OM. And actually, the second is you should fold this part MA along the direction of omega. You know, actually, its direction of VM is tangent line up here. Tangent line up here. This is VM, right? This is VM. So actually, you also can see, without draw this trajectory, you can think you first link OM, then you from this point M, you just along the direction of omega, you fold this MA a 90 degree. So maybe I will show guess another case. Maybe we have this OA along this direction omega. Then we can find this M, this VM. Then we can think that first we link OM, then we try to fold this MA part along the direction of omega, because this one is CCW. So we will fold this one with 90 degree, right? So we will get always perpendicular to this OA and this VM. See? That's how we find this VM, and its magnitude will always equal R omega. R means the length from O to M. The length from O to M, right? Always equal R omega. And alpha M, actually you can just find it should equal I'm sorry, this not alpha M. It should be AM. So do you guys still remember we have talked about natural coordinate. Actually, this AM will equal tangent part along tau direction plus AN along N direction. And this A tau will just equal this 1 dot VM. So it will be R alpha. So this A tau you should, because it have the same direction of omega, actually it will be A tau AT along this direction. And another one, AN will always equal V squared over rho, which will be omega squared R. Its direction will always point to the rotation center, right? So actually this one will be AN and this one will be AM. Then its resultant acceleration AM may be along this direction, that AM. So that what we have learned, and I think it a little bit hard for you guys to understand or grasp. So maybe you guys need to repeat to read our textbook and try to understand all this. And I think it's time for us to have a short break. We will restart our class today at 11 to 10. So please, you guys have a rest. Okay, guys, our time is up. Are you guys still listening to me? When I say we should have a short break, no one replies to me. It's more like that, no one are listening to me. This part is very difficult for you guys. Does anyone here can reply to me?
Yes, Laush.
Are you can still follow me?
Yes, Laush. We follow it.
Okay. So we will continue. It's so much, so I will maybe use other things. So we will finish this review and then we will start the new section of this chapter. So uniform rotation and rotation with uniform angular acceleration is very common use. So a body has uniform rotation when omega equal constant, and rotation with constant angular acceleration when alpha, that means angular acceleration equal constant. So these three expressions is always used. So or if alpha equal constant, then we will have omega equal omega 0 plus alpha t. So this omega 0 means when t equal 0, right? When t equal 0, so you can find omega equal omega 0. So this means boundary conditions. So, and another is this one. Actually, because we know omega equals d phi dt, so we only need to integrate this expression, we can get this. So phi equal omega 0 t plus half 1 alpha t squared. So it's very funny. It's very interesting in the third expression, you know? So we know we just integral the first expression, we will find the second one. But how we find this? So let me try to get this. So you can see it tells us the relationship between omega and omega 0, and it eliminates this time t, right? So we will try to use the first expression. Maybe I can write here. So we have omega squared equals the right part also should be omega 0 squared plus alpha t squared, right? Plus 2 times omega 0 times alpha t. Right? So we find actually this expression have omega squared equal omega 0. So we try to simplify this. So maybe this one is alpha squared times t squared, and this one. So I will try to do this. So we get this 2 times alpha. Then, so this one will be, it original should be alpha squared times t squared. Divide 2 alpha will be half 1 alpha t squared. And this part will be without 2 alpha because we use this set here. So it will be omega 0 times t. So you guys can find actually this is the same thing to this. We just rearrange the position of 2 alpha. So you will very interested find that actually this part is what? Is phi. Right? So that's why we have this expression omega squared equal omega 0 squared plus 2 alpha phi. Alpha is angular acceleration. So that's some expression. Maybe when we do some examples, we will use one of them, right? So I think that end review process of this. So we will move to the fourth section of this chapter. We'll talk about transmission between two rotating rigid bodies. So actually, this is very important term. Maybe you guys will learn in another course next semester. So this transmission, you guys can find its meaning from this title. Transmission between two rotating rigid bodies. Transmission in Chinese, we call that 传动比. I'm sorry, 传动比. Actually, it's a ratio. 传动比. It's more like this. So index I12 will equal N1 over N second. Also equal omega 1 over omega second. Right? That's what transmission is. So you guys can hear in engineering practice, several gears. Gear means in China we call that 齿轮. So you guys will learn in detail next semester. Several gears meshed with each other are usually used to change velocities of rotation and transmit power, which can be explained as follows. So transmission of gear wheels, 齿轮的传动比, that means 齿轮的传动比. So you guys can hear, here this figure we show two gears. The smaller one has this shallow blue color, maybe, and the bigger one has yellow color. Denote two gears. The first one, the smaller one, will rotate, have a rotate center with this. Maybe we can call that a 1. The yellow one is rotating center will be O second at here, right? So actually, these two gears will rotate around the different fixed point O1 and O second respectively. But actually, if this smaller one's movement is active, then it will let the yellow one rotate along the same direction. Just because the meshing, meshing means 啮合, means 啮合, because this smaller one have gear, 轮齿. Also, this yellow one also have gear. So these two ones will mesh together. So the gear, the tooth, the tooth, our teeth, the tooth of the smaller one will push the tooth of the yellow one. So when this smaller one rotates around O1, then the yellow one will have to rotate around this point O2, right? We call that inner meshing means 内啮合. So when we talk about inner meshing, these two gas will have the same direction of omega. So you can see this omega F denotes the bigger one, omega E denotes the smaller one, also along the same CCW direction, right? So that means at meshing point A, these two gas must have what? Should without slipping, hence its VF should equal VE. So according to the law of rotating of rigid bodies, so VF should, because VF means the bigger one, should equal omega F times RF. This RF is radiance of the yellow one. And VE equal omega E times RE, right? So this also is the vector equation. It means at meshing point, at this point A, gear 1 and gear E and gear F will have the same linear velocity with the same direction and same magnitude. No? So you can see from this, we will have this, then we'll give the concept of the transmission ratio. That is transmission ratio, we call that 传动比, you know? So here we have I, E, F. So this subscript letter E means the gear E, right? And F means the gear F. So we have the convention, the first letter will denote which is the active one, you know, which is active, 主动的. So that means this gear E will transmit pole to gear F, right? So that is very, very important transmission mechanism in engineering. So here we should know that. So this transmission ratio means omega E over omega F. It equal RF over RE because of this, right? And also equal ZF over ZE. This Z means number of tools, number of tools of a gear. So when we have a gear, its number of tools will be a constant number. Also should be integrity number, right? So let's say if this one have ZF equal maybe equal 0, then ZE equal not there 20 equal 40, then we will find actually IEF will equal half, right? 20 over 40 will be half. Then you will find actually we will have because 2 times omega E will equal omega F, right? So it just tell us the ratio between these two gears will always defined will be constant because the number of tools of each gear are fixed number. So this always a fixed number, right? So that means transmission of the gear wheels. Here we are talking about inner meshing, 内啮合. And we also have this. So this one will do not learn that. So you guys can find actually this two gears meshing its external meshing. We call that 外啮合. So this time we will find, so this is another figure to denote what is external meshing is. So you guys can find this smaller one is omega along CW direction, and this yellow one with CCW direction, right? This means omega D had the opposite direction with omega C. That's the main characteristic of external meshing. So when we talk about inner meshing, the active gear and the passive gear will have the same rotation of angular velocity. But when we talking about external meshing, just like these two gears will have opposite direction of angular velocity, right? You know? So once again, this point A will be a common point of this gear C and this gear D. So we also can use this. So it always should be VC vector equal VD vector. So actually, this means a point overlapping with A on gear C, and this point overlapping with A on gear D. So actually we see equal omega C times RC and VD equal omega D times RD. So from the same concept, we give ICD equal omega C over omega D. You know, we always use the first letter to denote which gear is active gear. The second one will be passive, 主动轮和从动轮, right? So why we give a minus here, minus sign? Actually, this negative sign means because it is external meshing. These two one will have different rotating direction, right? So it will equal minus RC over RD, also equal this one ZD over ZC. So you guys can find actually maybe inner meshing, maybe external meshing, but this gear mechanism will always have a fixed number of transmission ratio. No? 也就是说，齿轮传动的传动比是固定的 ，you know，传动比是固定的，或者是一个常数。固定的 means fixed. You know why? Why? You can say because it's always equal to the number of tools of this. Because this ZD will always be a fixed number, integral number, and ZC also another fixed integral number. Because actually this is used metal material, 金属材料 to manufacture into this gear. Have you guys have ever seen some part like this? Have you guys found some gears from your daily life? Have you?
Yes, Elijah.
Right? So actually we can count its number of tools. So we have 1, 2, 3, 4, 5, right? It's a fixed number, right? Fixed number. When we finish the manufacturing of a gear, the number is a fixed number. So this ratio always will be a fixed number. So that's the biggest characteristic of this gear transmission mechanism is its ratio always a fixed number, right? So another one is this. Actually, I write like this: I1 second equal omega 1 omega second, also equal N1 N second. So you guys once again should remember omega as units is radians per second, and N is RPM, right? Round per minute. It have different minutes because so it have a fixed relationship we always have. It will N pi over 30, right? So that when I talk about active gear means driving gear, right? And the passive gear is driven gear. It was driven by driving gear, right? So that's the transmission ratio of two gears. So it has some conclusion. Obviously, when I 1 second, its value, absolute value, less than 1. It means what? It means what? It means omega second greater than omega 1. Then transmission for increasing rotating velocity of driven gear. So you can find that. That means our driving gear is bigger than the driving gear. So maybe like 1 second, 1 second equal z second over z1 equal n1 over n second. So because this one over this one. It means then the second will less than the one, right? I think that's true. Is that true? So that means actually because this one it means this a second will greater than and one. So transmission for increasing the rotating velocity. So you guys can think about when you ride a bicycle, right? So although it's not a gear, but it's more like this. So you get confused when you are driving a bicycle. This bigger one we use our pedal, right? Maybe here, another maybe here. But like this big one rotate, then it have a link, a smaller one, right? Our bicycle wheel. So maybe we just let this bigger one rotate one round, then the smaller one will have a many round. So that means increasing the rotating, right? So, but when I 1 second greater than one, transmission for decreasing for rotating velocity. That's very common, very often used in engineering field, you know? So our driving gear almost driven by maybe a motorcycle, 电动机, electricity, motorcycle, not motorcycle, 电动机, you know? It cannot device when the electricity power is turned on, it will rotate, will highly speed. So this can 电动机 will have very high number of maybe 1400 RPM, right? So maybe we need to use some device to slow down or decreasing its rotating velocity to let our tools have considerable lower speed to do some things. So anyway, I only need you guys have a concept about this transmission. So there are another transmission system consisting belt and pulley. We call that 皮带轮, you know? 皮带 means belt, 皮带轮. So actually, you guys can look at this figure. When we try to use this kind of belt and pulley mechanism, we will try to make this AB, the length of AB, will large enough to let there enough pressure between this belt and this pulley. Actually, when this smaller one rotate, it is because the friction, you know, friction between this small pulley and the belt. This friction force will let this belt move along this direction. Because this belt always has big enough pressure onto this yellow pulley. Then also because the friction force, this friction force will let this yellow one rotate around the same direction of this omega A. So this omega A is the CW direction. So this omega B will also have CW direction, right? Actually, it's because the friction force. So we must try to let this length of LOA to be bigger enough to let this pressure between belt and pulley will bigger enough. So let the friction force to let these two wheels rotate together. See? So you can see at different point of the belt, we will have the same magnitude of velocity, right? So we will have this. So omega A times RA means the different point at here. Also the point on the belt. And omega B times RB, also this part. So because this moment will be continuous, so this expression will always be true. So from our definition of transmission ratio, we also have IAB equal omega A over omega B. So you guys, once again, this A at the first position means it is the driving pulley, and this B will be the driven pulley. So that means when this smaller pulley rotate, then this one also will be rotate. So that's another kind of transmission. You know, it's quite often used in our engineering field, right? So we also have pulley system. That means a lot of pair of this kind of pulleys. So it will be like this. So maybe it's very difficult and complex here today for you guys to understand. So we will just skip this one. Actually, you guys will learn this. Here we talk about the pulley system. We also have gear system, you know, gear system. So all these two things, you guys will learn that in detail last semester at another course, machine principle. I think Chinese name is 机械原理, no? Principle of machine and machinery, maybe 机械原理. So here, I just tell you guys like this. We just have impressive impression of this is this transmission ratio, right? So it's more like what we have talked about, the transmission ratio between a pair of gear, right? So this one will equal RB over RA. But you guys should know, actually, this will not a fixed number. It's not like the gear mechanism, because this belt will have elasticity, 弹性, elasticity. So maybe this is very, we call that 紧边, and this will 松边. That means the length will change from this side to this side. So that's not the characteristic we should learn at this course. Maybe you guys will learn that in future. You know, I just need you guys know this concept, transmission ratio, right? So let's move on. And then we move to the final section of this chapter 7. We'll talk about vector representation of angular velocity and angular acceleration. So you guys try to follow me and understand what this section will talk about. So the first we'll talk about vector representation of angular velocity and angular acceleration. So you guys look at the first picture. If we know that this yellow rigid body have a rotating movement around the fixed axis Z. So actually, the directions, and this figure also give the direction of epsilon. So you guess, I have mentioned actually here epsilon means angular acceleration. In my time, I think I'm old enough than you guys. Maybe my age is 2 times to you guys, right? You are so young. So in my time, actually, we use epsilon. Use this letter to denote angular acceleration, right? So this epsilon means angular acceleration 2. So it tells the direction of omega and epsilon are determined according to the right-hand rule. So you guys can recall how many times we have used this so-called right hand rule. So once again, you can use your right hand, right? You can use your right hand. I just try to show my right hand to you guys, right? So first we let our four fingers fold along the direction of omega, right? So then you will find your thumb will point along the positive direction of z. Why? Because the direction of omega and epsilon on the two figures are along CCW direction, right? Along CCW direction. So if we denote the omega with CW direction, you will find actually it will along the negative direction of z, right? So we can write like this, write like a vector. So we can write omega, it is a vector, it equal omega k. So you guys can recall that when we write a regular vector, it will have three components, maybe x along x direction and y along y direction and z along z direction, right? So here we use this omega equal omega k. It means it has zero component along x direction. It also has zero component along z direction, and it only have a component along k direction. Why? Because we almost talk about plane rotation, right? Plane movement. We just talk about the plane motion. So actually, this rigid body will move on this screen or rotate around some point, right? Maybe this omega. So you can see our omega will always perpendicular to this to this screen because our default coordinate always x point right, y point to upward, right? So our z direction always perpendicular to this screen. So our omega maybe CW direction, maybe CCW direction, always along direction of z, right? So it only have components along z axis. So for the same reason, we also have epsilon vector only have component along z direction too, right? That's how we use vector to representation of angular velocity and angular acceleration. Let's move on. So vectorial representation of the linear velocity and acceleration of any point in the region's body. So you guys pay attention to here, maybe a little bit difficult to understand. Actually, we know V should equal R omega, right? So you guys can look at this picture. So if we draw a vector R vector here, so this is the length of R, right? Actually, because this axis Z will perpendicular to this plane, so it will perpendicular to any line on the plane. So this one should be, so this CM, maybe this O will be a right triangle, right? So R omega can be rewrite as, we can use R because this is a right triangle. So R times sine theta will equal R, right? And then it is this. So can you guys remember, actually, we call that omega cross products R. Actually, its value will equal this. And this theta is the intersect angle between a vector omega and the vector R. So actually, it's use the reverse direction to find actually this one equals this, you know? So because omega R, because we see, it just seems like this part. So why this one equals this one and equals this one and equals this one. So that means we have this expression. When we use this vector, so this vectorial representation of the linear velocity means linear velocity V can be found use this omega vector cross product R vector. So do you guess you remember what we have when we talk about a force is a moment to a point? You know, you guess you remember what we have learned. It will be position vector R cross product force vector F, right? So it's more like this. It's more like this. So we have this V equals this. If you guys can understand this expression, then we can talk about its angular velocity. So we just use dv dt to find this because v vector equals this. So we just talk about d omega cross product r dt. So we can use the so-called I think should be 链式法则. I think string str string rules. It's also a mathematics knowledge point. So the first we do d omega dt cross product r this part, keep the original, and then plus this part, keep the original cross product dr dt, right? Then we can find, because d omega dt actually equal what? Equal epsilon. That is angular velocity. Cross product R and plus omega dr dt actually is V, right? It's V. So actually this one is AT, this one is AN. No, this one is AN. Because we always talk about plane motion. So actually our R and epsilon is although I think maybe it too difficult for you guys to understand. So I will try to. So you can see actually this part, a tau is this. Actually along, you know, from the natural, natural coordinate system, AT along tau direction plus AN along N direction. So we will have this. We will have this. So a tau equal this one. So after the norm of this vector actually is the norm of epsilon times r times sine theta times sine theta. This will be r epsilon. You know why? Because r sine theta. You know, r sine theta, from this you can once again find r sine theta equal r. So this is r epsilon. And AN equal omega cross product V. So we have omega V sine and then T. Because our omega always perpendicular to this vector V. right? So this will be 90 degree. So just this. Because V also equal another omega r. So we have omega squared r. So that's why we can see this vectorial representation have the same result. What we have learned, this is a tau, and this is a n. I think that out for this part, maybe it's a little bit difficult for you guys to understand, but don't worry. I think you guys just need to have a basic impression of this is enough. Actually, we will use this at chapter 8. I'm a little bit afraid to learn with you guys to chapter 8. So at that time, you guys will find actually chapter 8 is the most difficult than chapter 6 and 7. All we have learned today and the last time is the important basis for the knowledge of chapter 8. So maybe we only have about 9 minutes, so we just have one example to talk about. So you guys just listen to me, and maybe I will left homework for you guys to finish. So let's see. It tells the acceleration of weight A in the figure is AA will 1 meter per second squared. And its initial velocity, the V0, equal 1.5 meters per second. V0. Its initial velocity V0, and R, the bigger R, equal 0.5 millimeter, and the smaller R is 0.3 meters. So so actually these two wheels will rotate together. It's fixed one to each other. Will around this center have the same velocity, angular velocity, and the same angular acceleration. So actually, it will let this weight A move along the upward direction, and this will downward this direction. So it let us find the number of revolution of the pulley in 3 seconds, and the displacement of weight B in 3 seconds. The velocity of weight B at t equals 3 seconds, and the acceleration of point C on the rim of the pulley at the initial time. So you guys can find its process of calculation, try to understand, and the acceleration of point C at t. So let's see the answer. Can you guys understand? So the first one is, let's see, assume that the rope is not extensible, right? It always keep its length without any change. So we have, actually this point C is the point on the wheel, the yellow one. So it will have ACT and ACN, right? And this ACN, because it's also a point on this rope. So our AC tau will equal to the acceleration of A. So we will have this expression, AC tau will equal AA, will equal 1 meters per second squared. And then from the relationship, our angular acceleration, right? So we have AC tau should equal R acceleration. So that's the characteristic. We should know the expression because of this fixed rotation, right? It's fixed rotation around the fixed center. Then we can find epsilon is AC tau over a big R. It's this, right? And then our VC also equal VA should be 1 0.5 meters per second, and omega 0, you know? So here we see also equal omega 0 times r. So we can find omega 0 equal this, right? So then we should use this, the expression. We have to do this review, but I hope, I'm afraid that you guys cannot remember that. So maybe after class, you come back to that page and review this one. So we just use this expression directly. Maybe it's difficult for you guys to understand. So because we have omega 0, we have epsilon, so we can use this directly. So phi equal omega 0 t plus half epsilon t squared. We need to figure out when t equals 3 seconds, right? So we just use t equals 3. Substitute into this expression, we will find phi equal this. And its revolution means because one revolution will be 2 pi, so the n will be 2.86, right? The second one, so because the arc length of this will be r times phi, so we have the smaller one have radius r 0.3 meters times 18 rate, that the whole angular displacement in 3 seconds, right? So S equals this. And use this omega equal omega 0 plus epsilon times t. It should be this. And then VB will be omega times r, right? So that means omega 0 equals 3 rate per second, but after 3 seconds, it will change into 9 rate per second because of this expression. It is accelerated rotation, right? So I think the other things for you guys is quite difficult. So maybe you guys need to take your time to try to understand this. So since we don't have enough time, we just cover this quite speedy. So AC tau always equal AA, you know, because along the whole elliptic process, this AA will keep a constant value. So AC tau will always equal AA, equal this. But our ACN will equal omega 0 squared r at the start, but at the finish time point, it will equal omega squared r, right? So at t equals 0, it will be this. And at t equal 3 seconds, you will find AC tau always the same value, but this time ACN change into omega squared r, right? From 3 change into 9. So that's why it's different. It's different, right? And this is the first example. Today we have homework. I hope you guys can try to finish by yourself, right? So this actually is the first problem at our textbook. So you guys, maybe I can show you also at this. Really? See, you guys, actually this is the figure of the first problem. So our homework will be, I will select maybe I will just do this. This is our, I'm sorry. I'm sorry. I just sent it into the wrong position. Let me try. That is our group. So once again, I will just cut it for you guys. You also can find this in detail from our textbook. This is our homework today. So you guys can first try to finish by yourself. And we'll talk about this next time, right? So I think that's all for today. Bye bye, you guys. 今
Bye,
天就
老师。
上到这里吧，下课了，再见，朋友们，再见。
再见，老师。
OK，再见。